All right, so another very important thing that you do in calculus, something we have to become pretty comfortable with, is finding a table of signs. So there's a couple of ways of finding table of signs. I generally don't actually do what I'm about to do here. I kind of use how the function looks. So I'll show you both of those things. But once again, if you just want like a step-by-step of what to do for table of signs, here you go. All right, so we generally care about tables of signs in calculus when we work with rational functions, although we can do them for any polynomial. So the first thing we want to do is we want to kind of give it everything the benefit of the doubt. Let's pretend that the domain is all real numbers. Once you have like your entire domain, we're going to start to split this up into what are called subdomains, right? So our subdomains are going to be any place we have a vertical asymptote or any place we have an x-intercept. So we basically care about what's happening between x-intercepts or between vertical asymptotes or between x-intercepts and vertical asymptotes, right? So a couple of other things that are important, right? A table of signs, we care about how many negatives we get. If there's an odd number of negatives, then we know that a function is going to be negative. We'll see why in a second. If there's an even number of negatives, it means that your function is going to be positive. All right, so if I just jump to an example here, right? So this function, right, this rational function, pretty nasty looking. It has x-intercepts at -2, right? Because when I plug in x is equal to -2, right, that's going to make this numerator equal to 0. And also has an x-intercept at +1, because if I plug in +1, it's going to make that equal to 0. So notice that nothing canceled out of this denominator. So I'm going to have a vertical asymptote when x is 0. I'm going to have a vertical asymptote when x is equal to -4. This function has no holes. Holes, unless they're at like the x-axis, that don't affect a table of signs. Right, so I'm going to break this up according to these vertical asymptotes and x-intercepts. Right, so I have a vertical asymptote right here. Not important that it's a vertical asymptote, but that's a vertical asymptote right there. I also have an x-intercept here. I have a vertical asymptote there, and I have an x-intercept there. So the idea is that we want to take some value on this pretty big subdomain from -infinity to -4. Pick any value of x that lives in there. I'm going to say x equals -5. So what we do now is we think, well, what happens if I plug -5 into my function for every value of x if I evaluate it at -5? But I don't care again about the number. All I care about is what I'm going to get, positives or negatives. -5 plus 2, right? That's going to be a negative number. -5 minus 1, that's also going to be a negative number. -5, well, that's negative. And -5 plus 4, that's also going to be negative. Now, let's do a little bit more simplifying. If I have negative, if I have a negative value to the third power, it's going to stay negative. If I have a negative number and I square it, it's going to become positive. I have a negative that's just hanging out down there. It's negative. And I have a negative raised to a third power, so that's also going to be a negative. So if I look at how many negatives are left over, I have 1, 2, 3. I have an odd number of negatives. So this is going to be a negative number. So since I get a negative value on this entire domain, f of x, whoops, our function is negative. Now, if you want, you could also just kind of like count up how many things here. I have 3, 5, 6, 9, right? 9 is also a negative number. So, I'm sorry, 9 is an odd number. So you could also kind of like do things that way. All right, so then if I looked at, say, anything on this little subdomain from -4 to -2, well, the easiest value for me is -3. I'm going to pretend like I'm plugging -3 in. -3 plus 2, that's going to be a negative number. -3 minus 1, that's going to be a negative number. -3 is negative. -3 plus 4, well, now that's positive. All right, so once again, if I either count up the number of negatives that I have or just kind of simplify one more time, -3, sorry, negative number to the third power is negative. This is going to be positive. This is still negative, and a positive number to the third power is going to be positive. Well, now look, I only have 2 negatives, right? That's an even number. So this means my function is going to be positive on this subdomain. Don't just think that things are going to go negative, positive, negative, positive, negative, positive. That doesn't always happen. You actually have to check everything out. Right, so if I look at this domain, right, so just a little bit quicker, right? So this is, I'm going to pick some value like -1, x is -1. So I'm going to plug these things in. -1 plus 2, that's a positive. -1 minus 1 is negative. Negative is 1 is a negative number. That's going to be positive. It's always going to be positive from here on out. Right. So I'm going to get a positive number cubed. I'm going to get a negative number squared. I'm going to get a negative hanging out in the bottom. Positive number cubed is positive. I only have one negative left over. So my function is going to be negative here. All right, so I'm going to get a negative. If I pick something between 0 and 1, like a half, don't be scared of fractions. If I pick a half, because again, we don't care about calculating anything. We just care about whether it's positive or negative. So a half plus 2 is going to be positive. A half minus 1 is going to be negative. A half just right there is a positive number. That's also going to be positive. So I'm going to get a positive number. I'm going to get another positive number because I'm squaring over a positive times a positive. So there's no negatives at all. So we're going to be positive over here. And if I just pick something bigger than 1, like, I don't know, 77. I'm not going to pick 77, but it doesn't matter what value I pick, right? So I'm going to pick 2, obviously. So I plug in a 2 here. All right, so we're going to get a positive number, another positive, another positive, another positive. There's no negative, so this is also going to be a positive number. All right, so what this does for us, it tells us exactly where a function is going to be negative and where a function is going to be positive. So if we want to figure out where f of x is negative, so f of x is less than 0 on negative infinity to -4, right? So it's there, and also here, as well as -2 to 0, and it's kind of positive everywhere else. If I want to figure out where f of x is greater than 0, so it's going to be greater than 0 on -4 to -2. That's right here. Also from 0 to 1 here. Now we want to be careful. I said just greater than 0, not greater than or equal to 0. So then again, it's going to be greater than 0 from 1 to infinity. That would be the exact way to write what that domain would be.